Another topic we're going to discuss is split horizon. So this is talking about routing. A route advertisement method of preventing routing loops in distance vector routing protocols. So this is a specific type. You'll see a test question on this, which is why we're including it. This is a whole topic, just routing protocols. There's many different ones. Many different ones. So it's a little bit outside the scope here, but they have a test question on it. You may have a lab configuring routers, or from one of your networking classes, they're just asking you to recall this information. So split horizon is a route advertising method of preventing routing loops in distance vector routing protocols by prohibiting a router from advertising a route back onto the interface from which it was learned. So split horizon routing with poison reverse is a variant of split horizon route advertising in which a router actively advertises routes as unreachable. Instead of just preventing them, it actually advertises them as unreachable over the interface over which they were learned by setting the route metric to the infinite, or to infinite. So 16 for RIP. So it's just a fact, just memorize them. If you learn this from networking, this should be familiar. If you don't know networking, this should hopefully generate some curiosity and you'll go dig into what the routing protocols are. One of the things here we want to talk about is robtex.com. It is a tool. It's a Swiss Army knife of DNS. I highly recommend you go out and play around with this one. robtex.com. We'll have a lab on this. So again, this is kind of some overlap. We talked about where you're expected to know networking. This definitely comes from that. There's a few questions on networking in the test. This will be one of them. So CIDR notation for network descriptions, which stands for a classless internet domain routing or a classless interdomain routing. And you have networks like Class A, Class B, Class C. Here's a number of addresses that go with them. This is specifically talking about IPv4 networking. And then down below you have the ABCD/32. That notation is CIDR notation. That specifically says I have one IP address. The subnet mask, you'd have one IP out of 256 is what that's supposed to say. Out of 256. The ABCD 31, you have two IP addresses out of 256. So as the bits start to decline, you get more and more addresses. So it's like a balance, a sliding scale there. So then another type of notation is the ABC A.B.C.0/24 is 256 IP addresses. The A.B.0.0/16 is 65,000 IP addresses. A.0.0.0/8 is 16 blah 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 IP addresses. If you want to read more about it, there's an excellent wiki read. Also, subnet calculators can help with understanding this notation. Remember what I told you, you need to know how to compute or calculate subnet broadcast addresses from CIDR notation. Regional Internet Registries and related terminology. Regional Internet Registries, or RIRs, are a group that get together and manage DNS for that region of the world. They manage relevant TLD names, you know, the dot whatever, like .com is America, things of that nature. So the local Internet Registries are more regionalized, so those are abbreviated by LIRs. So they are Asia Pacific Network Information Center, or APNIC, Roso IP Europeans Network Coordination Center, or RIPE, and Latin America and Caribbean Network Information Center, or LACNIC, American Registry for Internet Numbers, or ARIN, and African Network Information Center, or AFRINIC. So those are your sets of RIRs. ARP, or Address Resolution Protocol. We've been discussing this quite a bit. Its purpose is to translate an IP address into a MAC address for when it gets near its destination. And also it does it vice versa. So IP to MAC, MAC to IP. Switches and routers use MAC, or a Media Access Controller, addresses. So switches and routers use these. to configure routes and all kinds of other things. We talked about routing protocols earlier. You'll see a lot of talk about ARP. It's a stateless protocol, therefore subjectable to man-in-the-middle attacks, such as ARP spoofing and things of that nature. There's no particular management of this. It's stateless. Network switches. Switches connect one port directly to another port. We talked about this earlier. They electrically connect them. So right now, if there's no data traversing the switch, there's no physical connections inside there, no electrical connections. The gates are closed in such a way where traffic can only be directed to the one port. So it doesn't connect two ports at a time unless you flood the switch with an ARP or ARP flood or a MAC flood, and then overrun the tables, and then they'll start electrically connecting everything all at once. So switches connect one port directly to another. They provide span ports that can be used to snoop on traffic, but can be limited by CPU and flooding, which turns them into hubs. We talked about that earlier. Network taps provide unfettered access to all traffic on a wire. Network taps provide unfettered access to all traffic in a wire. So you might have a tap here for that 4-port switch.